let's move right on to Antonin and to open source.
No, I don't need it.
I'd like to, yeah, you're okay, you don't, I don't
No,
think
I don't
you
have
need
any slides.
Okay, you don't have any slides. And I wanted to ask you particularly about RISC-V to start with, and what advantages it has in the world you're in, which is really, in a sense, democratizing some of these advances.
Okay, thank you for your question. Thank you for having me here. So let me first introduce my company. I'm part of OpenChip. So OpenChip is a startup company based in Barcelona. So we are a European, Spanish and European company. And we define ourselves as a fabless, full-stack silicon design house. So the aim or the intention of our company, we have been created to design and manufacture the next generation of RISC-V-based chips and software stack for AI and HPC acceleration. So a very long definition, but let me focus on the RISC-V part. Let me explain what RISC-V is, because probably most of us know it, but maybe not everybody, so let me put everybody on the same page. So RISC-V is not new, it has 15 years, but it's a new open source instruction set architecture, which is the definition of a processor, or the architecture of a processor. So there are basically three main architectures. One is x86, which is what is invented and owned by Intel, and this is what is powering all our computers and the majority of our servers worldwide, manufactured by either Intel or AMD. The other one is ARM, which is owned and defined by ARM Holdings, which is another company that defines this architecture. It's more like lower power, and it's what we have in all our mobile phones and many other places, cars, and many other places. So the third one is RISC-V. So what is new about RISC-V? So the main thing is that open source. So it's not owned by anybody, it's owned by a consortium of companies called the RISC-V International, which is a non-profit organization with many companies. We are part of that. And we basically define the common set of instructions that we use all together. What is the definition of the processor? So it's open, anybody can participate, and then we all agree on those instructions. So what are the benefits of doing this? Well, there are many. First, from the technical point of view, it's very easy to design your chips. It's the modularity of the chips, flexibility, like the energy efficiency. So the cores have been designed from scratch to be energy efficient. The scalability, you can go from microcontrollers to supercomputers with the same architecture. You can scale it as you need. You can add new features like security, for example. In Europe, it's very important, the security, so you can define new instructions or new features for security. So from the technical point of view, there are many advantages. From the business point of view, there are also some advantages. First one is that it's free, so we don't have to pay license to anybody. So this is a very, very important advantage. There are a lot of economies of scale, so there are a lot of companies collaborating in an open source model, so it's like bringing the open source model of the software to the hardware. So we are all collaborating, we can benefit of all the innovation and all the capabilities that other companies are doing and the compatibility, so we ensure that whatever we do is compatible with the rest of people doing the RISC-V processors. And the most important, another important one is that there's no vendor lock-in. So it's an open architecture, you have multiple vendors. We have many companies designing chips based on RISC-V. We are not the only ones. There are more in Europe and worldwide. There are many as well. So we are all compatible because we have agreed on this common set of instructions. There was a question this morning why do customers care on the microarchitecture? So the top level using an AI service, for example, do they care about what architecture or what microprocessor is running on? The user doesn't care. It's true. I mean, they want a service. But they care about having a fast service, with low power, with fast response time. And the people like us that are trying to design those chips, for us it's important, the first decision that we have to make is what is the architecture that we're going to use. And from that point of view, the RISC-V have a lot of advantages because what I said is also it's impossible. We are doing this hardware and software co-design from the beginning. So the software is a very important part of the success of an architecture. If you do proprietary, you have to do all the software, all the libraries, compilers, frameworks, etc., needed to run, because at the end, applications run on other architectures. You create a new one. It must be the best architecture in the world, but you don't have any software, so it's useless. In the RISC-V ecosystem, we have a lot of software people because software is key to the success of our company. But we also benefit for we can reuse all the pieces of software and also all the silicon design that has already been made, so we don't start from scratch. So from our point of view, it's all benefits. By the way, Osman, you're also expert in RISC-V. Feel free to chime in and give us your opinion.
Definitely. I think the lack of this licensing. If you go with ARM, the next economical choice, the architectural license is on tens of millions of euros. So that gives a chance for the European SMEs, such as our sister company, to get a head up, because RISC-V has zero licensing cost.
Yeah. It's more difficult to promote the standards. So you want to set a new standard for security. In the case of ARM or x86, you have to convince either ARM or Intel to do that in the silicon. In the RISC-V ecosystem, you can add your extensions and then publish them so that others can use it as well. So it's a very open ecosystem. They're not hearing you, so I think.
Thank you.
Okay, now.
Let me ask you a little bit more about this issue of European digital sovereignty and the kind of issues that companies face when they try to design and manufacture with the goal of reaching digital sovereignty.
Yeah, so we have digital sovereignty, European digital
Right.
sovereignty in mind from the very beginning. We were creative for that, to create technology in Europe. So when designing and manufacturing technology, there are several challenges, but we are designing, we are fabless. We don't plan to build a factory because that's another set of problems. So we're gonna design the chip and then ask somebody to manufacture it. Actually, there are only 3 candidates, which is TSMC, Intel, or Samsung, that do have the top edge or the lowest node, or the smallest nodes that we need for this type of product. What are the challenges? It's very obvious. I'm going to repeat some of the things that have been said this morning, but the first one probably is funding. So this is it's required a lot of money to all this, with a lot of people to do this type of adventure.
Is that really an issue in this country where there's, how many, $12 billion?
I think there used to be 12 billion.
Maybe there's 11 left?
I don't know. There are some
Spain
news.
for investment?
Some news are saying that they're not there anymore. Very risky.
Well, I don't know, but we are funded by the European Union, so we have a grant from the European Union. This is when the company started, when we got this grant, and it's not that big. I don't know the exact number, to be honest, but we have some funding from the European Union, but I think this is key, otherwise it's impossible. We need the companies trying to do this need funding from both the governments and from the private industry, otherwise it's impossible to do this type of adventures, because you need a lot of people, which is, by the way, the second challenge, finding the right people, the talent. So we are happy to say that we have repatriated, I don't know if I can use that word, but we have bring back a lot of people to Europe, from the US, from Asia, from Japan, from many places, also then European people that had to go abroad to work on semiconductors, on chip design. We have brought people from Intel, from NVIDIA, from Google, from NEC, from IMEC as well. So we have a lot of people coming from different places in the industry to create this group of people that can do this challenge. And probably the third challenge, as I said this morning, is time. So we wish that we had the magic of doing something and then it would be ready tomorrow, because this is a race against time. We do a design now that we're going to test in 2, 3, 4 years, and then let's see how fast it is, and also how fast it is compared to the technology at the moment. So it's difficult to predict the future, but we need to do it because we need to decide what is going to be top-edge technology in 2, 3, 4, 5 years, so it's difficult.
So time, money, talent,
Yeah.
the 3 things.
3 Ts, okay.
Yes.